Free software means software that respects the user's freedom. There are 4 essential freedoms that the user of software should always have. Freedom 0 is the freedom to run the program however you wish. Freedom 1 is the freedom to study the source code of the program and change it to make the program do what you wish. Freedom 2 is the freedom to distribute copies of the program to others when you wish. Now this includes republication of the program. And Freedom 3 is the freedom to distribute copies of your modified versions to others when you wish. And this also includes publication, if that's how far you wish to go. If you have all 4 of these essential freedoms, then the program is free software, which means that the social system of the distribution of this program is an ethical system that respects the freedom and community of the users. If one of these freedoms is missing, then the program is proprietary software, meaning that it keeps the users divided and helpless and gives the developer power over the users. This is an injustice. Proprietary software should not exist and should not be used. If you want to have freedom, the only way you can have it while using computers is by rejecting proprietary software.
The first thing we need to do is create our installation medium. So we're going to use disk utility to format our flash drive. Next, we're going to open up a terminal window where we will first type diskutil list. That's going to give you the names of all connected devices. We can see that the flash drive I connected is currently labeled as disk 2. Dev is the directory in which it's found. I believe it's short for devices. Next, we need to unmount the flash drive, which we will do by typing diskutil unmount disk dev disk 2. And finally, we're going to type sudo dd if equals. Then we're going to drag our ISO into the terminal, which is going to complete the file path. Then we're going to type OF equals dev R, and then the name of our disk, which again in my case was disk 2, and then BS equals 1M. And it's going to ask for your password, since by using the sudo command, we are running this with root access. And once it's finished, you're going to get this error message saying the disk you inserted was not readable by this computer. Just hit ignore. I'm still on macOS, but I've booted into a virtual machine. This is an installation I did just to download packages, so there's no DE installed. The USB drive that we're going to be using as our repository is connected, and we're going to format it to ext4. Next, we'll mount it to the MNT directory. And then we'll create a directory to which the packages can be downloaded. And if we change directories and do an ls, we'll see that we have successfully created the directory. Now we need to generate a list of the packages to be downloaded. We're going to do that by typing pacman sp base devel. These are the absolute bare minimum you need to install Arch Linux on your system. But since the idea here is to get our Wi-Fi up and running without an Ethernet connection or burning through phone data, we're also going to need DKMS, which is Dynamic Kernel Module Support. That's going to allow us to use our wireless driver, which we'll get by downloading Broadcom WL DKMS. And we're also going to need Linux headers, and finally, Network Manager. And we're going to output this to MNT, which is where our USB is mounted. and we're going to call it packages.list. And now if we do an ls again, we can see that packages.list has been created. Next, we're going to download those packages by typing wget p mnt packages -i mnt packages.list. Got a whole bunch of error messages because one of the mirrors is offline, but now that that's finished, now we're going to copy var cache pacman pkg asterisk to mnt packages. And if we change into that directory and do an ls, we find our packages. Now all we got to do is make this into a repository. The command we use for that is repo add packages.db.tar.gz. Then we're going to specify what's to be converted. We want to convert everything, so we're going to type *.pkg.tar.xz. That ran fine. So now we're going to power off our virtual machine and proceed to the next phase. We've now booted into our installation medium. We're going to do an lsblk, or list block devices, and that's going to give us the name of our main internal drive. In this case, it's SDA, so we're going to type cgdisk dev SDA. Now I'm in a VirtualBox right now because I wanted to use the screen recorder for this, but I set up these partitions ahead of time to simulate what you're going to see if you plan to dual boot with macOS. There's going to be this 200 megabyte EFI system partition. This is the default bootloader that was created when you installed macOS. Apple Core storage is going to be where macOS is actually installed. And then there's going to be this recovery partition. Leave these three alone so you don't disturb your macOS installation. And then delete everything else so that you have free space here. At that point, you're going to select New and hit Enter. For first sector, we want to leave that to the system to determine automatically. So we're going to leave this blank and just hit Enter. For the size, this is going to be our swap partition. The rule of thumb is to give it twice as much memory as you have in RAM. I gave this virtual machine 2 gigabytes, so I'm going to assign the swap partition 4 gigabytes. The hex code for this is going to be 8200, but if you need a list of all the hex codes, you can hit L, and that'll bring it up. You can see towards the top of the right-hand column, Linux swap is 8200. So just hit Enter to exit that, and then type in your hex code. And we're going to name it swap. Next, go down to your free space and once again select New. Leave first sector blank. Size, this is going to be our root partition, which generally you want to give between 15 and 20 gigabytes. Hex code for this one is going to be 8304. And we're going to name it root. Next, hit New again. First sector blank. Size blank, which is going to allow it to take up whatever memory is remaining. Hex code, it's already on Linux file system, so we're just going to hit Enter. And we're going to call it Home. So next, you're going to want to select Write, hit Enter, type Yes. Then we're going to quit, clear, and we're going to do lsblk again to make sure that our new partitions are showing up. Excellent. There they are. Now we need to format our partitions to the proper file systems. We'll start with the boot partition, mkfs for make file system, fat-f32 for fat32, dev sda1. Next, we're going to type mkswap, and our swap partition was dev sda4. Then we're going to initialize it by typing swap on. And then for our root and home partitions, we'll be using ext4. And now we're going to mount our partitions. The order here is very important. We're going to start with the root partition, and we're going to mount it to the MNT directory. Next, we need to create directories to which the boot partition and the home partition can be mounted. So mkdir for make directory, mnt home, mkdir mnt boot. And then we're going to mount the partitions to their respective directories. So mount dev sda6 mnt home and mount dev sda1 mnt boot. Now we're going to install our packages. Since our partitions are mounted on the MNT directory, that's where we want to make a new directory for the flash drive currently storing our packages. We'll do this with mkdir, mnt, and we'll call the directory USB. Next, we'll mount the flash drive. And if we change to that directory, we're able to see the contents of the flash drive. Now we're going to copy the contents of the flash drive with cp, r for recursive, mnt, usb, asterisk, and we want to copy it to mnt. Now if we check the MNT directory, we'll see that the contents of the flash drive were copied over successfully, and we're going to go ahead and check in the packages directory, where we just so happen to find our packages. Based on the fact that you're watching this video, I'm going to assume that you've probably heard of Vim or Emacs before. If not, both of those are just command line text editors. Using a similar but much simpler program called Nano, we're going to open up a file in etc. This is the directory where you'll generally find your configuration files. And the configuration file we want to open is pacman.conf. So we're going to use our arrow key to travel down to this list of repositories. And we're going to comment out these lines by adding pound signs to each line that doesn't already have one in front of it. At the bottom of this file, you can see there's a template for how to add custom repositories. And we're going to follow it in making use of our flash drive. We named our folder packages, so that's what we're going to put in brackets. Underneath that, we're going to put sig level equals never. And sig level is camel case, which means the first letter of each word is capitalized. Underneath that, we're going to put server equals file : / Then we need to specify where our packages are found. So /mnt packages. We're going to save this by hitting Control-O, and then we're going to exit by hitting Control-X. Now we're going to type pacman sy to sync our package manager, and we can see that our custom repository has been added. Now normally to install packages you would use the command pacman-s, but we're going to use a special command called packstrap, which as far as I know is only used during the installation. So packstrap-i for install. Then we need to specify where we want the packages installed. Our root partition is mounted on the MNT directory, so that's what we'll put down. And then we need to specify what packages are to be installed. So base devel, Linux headers, DKMS, Broadcom WL DKMS, and network manager. Now you may notice after using the lsblk command a few times that the names seem to be set somewhat randomly. Your computer sometimes loads the file systems in a different order, and so we're going to generate what's called an fstab, or file system table, which is basically a configuration file that looks for specific file systems and then mounts them automatically in a desired way each time. So we're going to type gen fstab -u This is going to allow us to use UUIDs as our source identifiers, MNT, and we're going to output that to MNT etc fstab. Then we're going to use nano to double check. And everything seems to be in order, but I forgot to unmount the flash drive that contained our packages. So you'll notice here at the bottom that flash drive got its own entry in our fstab. I'm going to delete this to prevent error messages when we reboot into our system for the first time. It's over. Now up until this point we've been working from the ISO, but now we're finally going to switch into our actual system using the command arch chroot mnt. Our first order of business is to generate our locale. So we're going to use nano to open up etc locale.gen. Then we're going to hit Control W to use the search function and then type in our locale. Mine is enus.utf8. So I'm going to hit enter, and then I'm going to hit Control W a second time and hit enter. And that's going to take me to this line, which I will uncomment, save, exit. And now we're going to type locale gen. Then we're going to echo lang equals n us utf8 to etc locale.conf. Then we're going to export lang equals en us.utf8. Now we're going to set our system's host name, again using the command echo. Then we're going to specify the name of our machine. I'm going to use my machine. And we're going to output it to etc hostname. Then we can go ahead and open that up with nano just to make sure it worked. And there it is. So at this point, we're going to set the root password for our system by typing passwd, and then we're going to enter our password. Next, we're going to add our user account using the command useradd -m, which will give us a home folder, G to specify group. In this case, it's going to be users, capital G for subgroups. The subgroup we're going to be using is wheel, and then S for shell, which is going to be bin bash. And then the name of our user, I'm going to go with works on. Next, we can set the password of our user using the same command we used to set the root password, but this time we're going to add our username to the end of it. Almost forgot, but this is a very important step. Right after making our user account, we're going to type editor equals nano visudo. And then you're going to hit Control W to search and type %wheel. If you'll remember, we just added our user to the group wheel. So we're going to uncomment this, and then underneath, we're going to type defaults root password. This allows your user to have root access for individual commands using sudo, which is a lot more secure than just having root access all the time. So we're going to save and exit. Now we're going to install our bootloader with the command bootctl. Path equals boot install. Next, we're going to type blkid for block ID, S, part UUID, O, value, dev, and then your root partition, which in my case was SDA5. And if we hit enter, we're going to see the part UUID as the output. So we're going to take that same command, but we're going to output it to bootloader entries arch.conf. And I misspelled entries, so I'm just going to fix that real quick. And if we open that file up, we're going to go to the beginning of this line and type options root equals part UUID equals. Then we're going to go to the very end of the line and add RW for read write. Now above this line, we're going to add title, Arch Linux, Linux, VM Linux, Linux, and then underneath that, init rd, init ram fs -linux.img. We're going to save this and exit. Now we're about to reboot our system, unplug the installation media, and then boot into Arch Linux for the first time. But since we installed Network Manager, what we're going to do first is systemctl disable dhc pcd and systemctl disable netctl. And then we're going to do a systemctl enable Network Manager. And next we're going to type exit. We're going to unmount our MNT to unmount everything. Then we're going to shut down our machine, unplug the installation medium, and reboot into Arch Linux for the first time. So we've rebooted, we've logged in as root, and to get connected to our network, we're going to type nmcli for Network Manager command line interface, device, Wi-Fi, list. That's going to give you a list of all the available networks. All we need to do now is type nmcli device, Wi-Fi, connect, then the name of our network, password, and then the password to your Wi-Fi network. And now if we ping a website, we have Wi-Fi. Now that we're up and running, we've got our Wi-Fi working, we're going to go back and edit our etc pacman.conf file. We're going to hit Control-W to search, type multilib. We're going to come down here and uncomment it. And then we're going to add the Arch user repository. These are packages which are very useful but aren't officially supported. So in brackets, we're going to put Arch Linux FR, and underneath that, sig level equals never, and server equals http repo.archlinux.fr/$arch. We're going to hit Control-O to save this. We're going to exit with Control-X. And we're going to do a pacman sy to once again sync. This is one of the first things I'll do if I'm installing Arch Linux and have an internet connection from the beginning. We're about to install our desktop environment, which involves quite a few packages. So to make that more efficient, using Nano, we're going to open up etc pacman.d/mirrorlist. We're going to exit. We're going to cp the file we just opened. So etc pacman.d/mirrorlist. And the copy is going to be named etc pacman.d/mirrorlist.backup. Next, we're going to type sed-i, and then in quotes, s/caret, # server, and we're going to replace all instances of # server with server. So we're going to close that up, and we're going to apply this to etc pacman.d/mirrorlist. Next, we're going to type rank mirrors, n6, and then the file we've been dealing with, etc pacman.d/mirrorlist. So now we're left with a list of the 6 mirrors to which we have the best connection. We're just about ready to install our desktop environment, but we've got a problem since we're using an Apple keyboard. Our tilde key is giving us this as an output, so we need to create a configuration file to fix that. We're going to do that by typing nano etc modprobe.d, and you can name this anything you want. I'm going to name mine keyboard.conf. And in this file, we're going to put options, HID Apple, ISO layout equals 0. We're going to save and exit, and our tilde key should be working at this point. Now it's finally time to install our desktop environment. We're going to use pacman s. The first thing we're going to need is an X server. So the first package we're going to download is xorg server. Then we're going to need xorg xinit. Next, we're going to put our desktop environment of choice. For this video, I'm going to use xfce. And if you're using GNOME or xfce, you're also going to want to install Network Manager Applet, which is going to give you Wi-Fi functionality from your taskbar so you don't have to keep connecting through the command line. Now when we start our X server, we want it to launch our desktop environment automatically. So we're going to open up xinit rc, and we're going to add an execution command for our desktop environment. And now for the moment of truth, we're going to type start X to start our X server. So here we are. If all went according to plan, we're now in xfce. Obviously, I've made a few minor tweaks to the appearance of mine. Now we're just going to put a few finishing touches on our system. The first of which is to install Intel Ucode. Then we're going to go back into Bootloader, entries, arch.conf. And between the second and third lines, we're going to add initrd intel ucode.img. We're going to save and quit. That's going to make it possible for the Linux kernel to apply microcode updates to your processor during boot. Next, we're going to type lspci grep vga. And since this is an Intel system, for our video drivers, we're going to install Mesa and xf86 video Intel. And the last thing we're going to do is install TLP, which is going to improve the battery life considerably. Due to the fact that everything's configurable, there's obviously a hell of a lot more that can be done to optimize the system for this hardware, but that goes beyond the scope of this video. I wouldn't be opposed to making another video going into more detail about that stuff, but that definitely depends on the interest and feedback this video gets. If you ever want to go through all this information again, but maybe not sit through this entire video, there's a link in the description to a post on my blog where you'll find all the commands used in this video listed. Thank you for watching.